Hello and welcome to the final video in our asymptotic analysis series. We will be covering Big Omega and Big Theta. We've already learned Big O. Recall that if we had one expression on this side, such as this expression 1000x plus 2 log x, and we had another expression on the right side, such as x squared, we compared them by saying less than or equal to, then we got rid of the constants, we took away the lowest term, and then we compared whatever was left over. For Big Omega, we're going to do the same thing, so we just get rid of 2, we get rid of the lowest term. This time, however, instead of comparing less than or equals to, we're comparing greater than or equals to. So this is Big Omega right here, we represent it with this, Big Omega of x squared. And essentially this just means if this is in Big Omega of x squared, then this should be lower bounded by x squared instead of upper bounded. So as we can see, x is not greater than or equal to x squared, so x is not in the set Big Omega of x squared. A quick note on notation. Once again, it's possible to use this equals notation to mean the includes. So Big O was less than or equal to. Big Omega is greater than or equal to. Big Theta just means that it's in both Big O and Big Omega of something. So if f of x is in Big Theta of something, then it must be in Big O of that something and Big Omega of the something. So Big Theta essentially means it grows at approximately the same rate. So here we're asking x to the fourth plus 3x plus 9, is this in Big Theta of x to the fourth? We solve this in a very similar way. We get rid of the constants, we get rid of the lower terms, and we're left with x to the fourth. Now, to answer this theta question, we're going to break it up into two questions. Is x to the fourth less than or equal to x to the fourth, and is x to the fourth greater than or equal to x to the fourth? And the answer to both of these is yes. So essentially what this boils down to is this side equal to the right side? Occasionally you'll come across a case where it will look like it should be the same order, but it's not. So in this, we have x. We're asking, is it in Big Theta of x cosine x? And to do that, we ask, is it in Big O, and is it in Big Omega? To solve that, we're going to graph it. And don't forget that we only care about positive functions, so we surround anything that could go negative in absolute. And here we see that x is an upper bound, but there's no way to make it a lower bound. Even if we made this x a really small number, it could only get so low, but x cosine x would always jump to 0 occasionally. So we can't make x a lower bound, we can't make x into Big Omega, and because of that, x is not in Big Theta. X is only an upper bound, so x is only Big Omega. If we were to flip that around, we could say x cosine x is lower bounded. If we were to flip that around, we could say x cosine x is upper bounded by x. That is, x is always greater than or equal to x cosine x. This series covered the basics of asymptotic analysis. I hope you found it beneficial, and I hope you found the examples relevant. Thanks for watching. Bye.